All right, good morning, guys. I apologize. I'm out today. Had to take a sick day. Unfortunately, our sitter had an appointment, and I also have to take in my daughter to checkup as well. So I'm just going to make a quick video for you guys to go through the notes for today, and then you can do the practice at the bottom, and then I will answer any questions tomorrow when I return. All right, so first things first, I want you guys to go ahead and try these two on your own. This is a warm-up from content from last year. So you're going to evaluate or simplify the following two expressions if n equals 3. So go ahead and do that for both expressions. Pause the video. Okay. Hopefully you've done that already. If you have not, that's okay. Maybe you forgot how to do it, so that's why I put this in here. This is not a learning target for today. This is already an expectation, okay? All right, well, let's go ahead and plug this in. So n equals 3, we're going to plug it in for this n value. So we've got 2, and then 3 plus 1 minus 5. And then from there, we're just going to use PEMDAS. You guys might remember that. To simplify that as quickly as possible. Okay, so in this case, there's no exponent, but we do have a parenthesis, which starts first. So we've got 2 times 4 minus 5. No exponent. So we're good there. Multiplication, anytime that we have a parenthesis, like we do here, that is actually a multiplication problem. So this is actually 2 times 4, which is 8. Okay, so multiplication is done. There's no division, no addition. So we go to subtraction. 8 minus 5 is 3. Okay, so if n equals 3, then this entire expression equals 3. We're not solving for n, we're just simplifying the expression. Okay, let's do the same thing here on the right. This is supposed to be n, not x. Okay, but let's go ahead and plug that in. So it's going to look like this. If n equals 3, plug in a 3. I use parentheses when I substitute. Okay, next would be parentheses, but what it means by parentheses, notice the difference here. So when we do PEMDAS, this was something in parentheses because there is an operation we can do inside of it. This is not. Okay, this is multiplication here. So this is parentheses, this is multiplication. Two different things. Okay, so once again, checking. Okay, no parentheses, we're good. No exponent, we're good. Okay, multiplication or division. Well, we do have multiplication now. It is this, right? So we're going to calculate that. 2 times 3 is 6, minus 2 divided by 3. Okay, so that then gives us 6 minus 2, which is 4 over 3. And unfortunately, this comes out to be a fraction, but that's okay. We got to work with fractions anyways. All right, so we're going to do the same thing here. Okay, I want you to go ahead and, once again, pause the video now that you've seen how to do this. I want you to pause the video, and I want you to try to do that for the same thing for this one. It's a little bit more complicated. Okay, and if you can't remember how to do it, then just follow along. But evaluate the expression. So we're going to plug in each of these numbers, right? So 5 is what we're going to plug in first. So we've got 5 squared minus 9 over, and again, I'm using this equation, 2 and then 4 minus 3 in parentheses. Okay. All right, I'm going to go ahead and simplify that. 5 squared is 25 minus 9 over 2 times 4 minus 3, which is 1, equals 16 over 2. And 16 divided by 2 is 8. Okay, so there's one solution. Okay, I'm going to do the same thing. And again, if I get going too fast, please pause the video. Make sure you're getting it all down. Okay, but I'm just trying to make this video somewhat short for those of us that may already kind of know what we're doing. Okay, so we're plugging in a 7 this time. That gives us 49 minus 9 over 2 times 4 minus 3 is 1. 49 minus 9 is 40 over 2, which is 20. Okay, next one. 13 squared minus 9 over 2 times 4 minus 3. 13 squared, might not know, but probably should. It's 169 minus 9 over 2, and then times 1. So this is 160 over 2, which is 80. Okay. Negative 1 quantity squared minus 9 over 2 times 4 minus 3 equals 1 minus 9 over 2 times 1, which is negative 8 over 2, which is negative 4. Okay. So I know I went through that pretty quickly, but what do you notice or wonder about the results? Okay, I want you to write something down here. I'll just tell you what I notice is that all the results were even. It's interesting, 8, 20, 84, which made it very easy for us to divide by 2. Okay, well, why would that be the case? Because we had odd here, right? But when you square a number, okay, well, I was going to say when you multiply a number times 2, it makes it even. But when we're squaring a number, we're just getting the perfect square of that, right? But in this instance, I gave you all numbers that ended up being odd when you square it. Ended up being odd, which then when you subtract to 9, made it an even number. And of course, the bottom stayed the same for all 4 examples. So then when you have an even divided by 2, well, then it stays even, right? Okay, let's keep going here. So the 6.2 activity, much ado about ages. We are going to write as many equations as possible that could represent the relationship between the ages of the 2 children in each family as described. Okay, so in example 1, it says in family A, the youngest child is 7 years older or younger than the oldest, which is 18. So again, we're doing an equation here. So a couple ways to do this. We could say that the oldest is 7 plus the youngest equals the oldest. I'll use X for the oldest. Okay. We could also say that the oldest, which is X, and the youngest is Y. Make sure you always identify who's who. The oldest minus 7 equals the youngest. Okay, so there's a couple of different ways that you could write that, and there's actually a few more past that as well. So if you can think of a couple more, try to put them down. Okay, in family B, same thing. I want you to pause the video if you can. Family B, middle age, 5 years older than the youngest child. So try to fill that one out. And again, you're writing an equation. Okay, so middle child, let's call them X. Youngest child, Y, 5 years older. Okay, so the middle child is 5 years older than the youngest child. So the middle child is, now notice that I'm using the word is in both circumstances. Is 7 is an equal sign, okay? Is 5 years older than the youngest child. So Y plus 5. Okay, and you could flip that as well and say that X minus 5 equals Y. Okay, and all we did there is we're saying that the middle child minus 5 equals the youngest child. That's all. Okay, so hopefully you can see how these are equivalent expressions, and that's in our equations, and that's kind of what we're going through today is just equivalent equations here. So we've got these 4 as well. We want to see which one's equivalent to each other, and what that means, genuinely speaking, is that they have the exact same solutions. Okay, so let's go ahead and solve all 4 of these and see which ones are equal. All right, so the first thing, if you recall from last year, that we're going to do for this is we're going to subtract 6 from both sides. So that leaves you with 3a equals 9. Well, we already know that these 2 are good. Okay, we already know that they're going to be congruent because of the exact same equation. Once I've subtracted 6 from both sides, divide by 3, and that gives you the a equals 3. Okay, same thing on the next one. We've got 3a equals 9. Well, we just did that up here as well. Divide by 3, and that gets you a equals 3. So far, first 2 are equivalent. Okay, third one, a plus 2 equals 5. How do we get a by itself? Subtract 2 from both sides. That gives you a equals 3. Also the same thing. And then lastly, at the bottom, okay, so this is an expression or an equation with a fraction in it. And we talked about last week what to do in those circumstances. You multiply by the reciprocal. So what we're going to do is actually multiply here by 3 over 1. Multiply by 3 over 1. Okay, that's going to give us a, because these cancel, equals 1 times 3 is 3. And then divided by 1, which is 3. So it turns out all of them are equal. Even though they look different initially, they're all equivalent because they all have the same solution. Okay, moving on. Noah is buying a pair of jeans and using a coupon for 10% off. The total price is $56.70, which includes $2.70 in sales tax. Okay, so we got $2.70 in sales tax. We've got total price is $56.70, and we've got a coupon for 10% off. Okay, Noah's purchase can be modeled by the equation x minus 0.1x plus 2.70 equals $56.70. Well, I think we can tell right there that this is going to be the 10% off. Okay. Total price is $56.70. You can see how that goes on the right. And we've got the $2.70 for sales tax. Okay, so it's all listed out here. All right, it says in this equation, what does the solution really mean? So we're not solving it for this one. We're just saying, what would X mean in this case? Well, if this is the total price he's going to pay for a pair of jeans, and you've got 10% off and sales tax, what do you think the X represents? Hopefully, you're thinking the same thing as me. X is the price of jeans. How can you verify that 70 is not a solution, but that 60 is the solution? All we're going to do here is plug them both in. Okay, so is the pair of jeans $70 or $60? So if we plug in a 70, and I'm talking about this equation, so you got 70 minus 0.1 times 70 plus 2.70 equals 56.70. Okay, plug them in and go. So 70 minus 0.1 times 70 is just 7, plus 270 equals 56.70. Okay, 70 minus 7 is 63, plus 270. So that gets us $65.70. Is that equal to $56.70? It is not. So 70 is not a solution, right? Okay, do the same thing for 60. So plug in 60 minus 0.1 times 60 plus 2.70 equals 56.70. Okay, so you've got 60 minus 6 plus 270 equals 56.70. So this gives you 54 plus 270 equals 56.70. And if you look at that, 54 plus 2 is 56. So this one is going to check out, right? So 60 is the price of jeans. Okay, you're going to do the same thing here for this table now. Basically, we're saying that, and by the way, you could obviously use Desmos as well to like check some of these equations. Like if I plugged all these into Desmos, I'll just kind of show you what that looks like. Just real quick, and you can do that for the cool down. Actually, I'll show you here in a moment when we get to the cool down part. Okay, so the next part says, for the following are some equations that are related to the original, okay? And each equation is a result of performing one or more moves on that original equation. Each can also be interpreted in terms of Noah's purchase. For this equation, determine whether what move was made, then check if 60 is a solution to the equation. You can use Desmos. Okay, so in this first equation, how is it different than this first one that we had originally? Okay, what did they do? What did they do? I hope by putting it just like that underneath that you can see the same thing that I'm seeing. Okay, they multiplied by 100. 2 times 100 gives you 200. And anytime you have the decimals, you have to move them over. So what was done here? All multiplied by 100. So since everything was multiplied by 100, and you could have even wrote that they put this in cents, is 60 the solution? Yes. Okay, we could plug that in a Desmos, but you don't need to because it's the exact same equation when you multiply everything by the same number. Okay, if it looked like this instead, if it looked like that, that would be not same or equivalent expression and not the same answer. Okay, and if you don't believe me, try to plug both of those into Desmos and see if they match up. So watch what happens when you plug this into Desmos. Oops. All right, watch this. Plug them in both very quickly. 100x minus 10x plus 270, and I apologize for the style is clicking, equals 5,670. Okay, and then you've got, and let me just zoom out so we can see it. Okay, so there's that, right? You see that line? It's actually a vertical line right now because we have things on both sides. I'm going to do the same thing. X minus 0.1 x plus 2.70 equals 56.70. And look at that. Notice how they're both the same line and their solution is 60. Okay? All right. So you just have to trust me on this. I'm trying to make a quicker video here. Okay, so what was done with this one? So again, the original was this. Okay, so what's missing from the top? Missing the 270, and this number is different, right? Well, what is 5670 minus 270? It's 54. So what did they do here? They subtracted 270 from both sides. Well, as you learned last year, that's an equality property. It's called the subtraction property of equality. And so that means it's going to have the same solution because it's still the same equation. You just subtract it from both sides. Okay, you're allowed to do that. It's kind of like having a seesaw or teeter-totter, right? Okay, so let's say I've got a teeter-totter that looks like this. You've got kids that are standing here or sitting here, kids are sitting there. If I remove one from each, it's still level, right? And that still checks out. Same idea. Okay. All right, next one. I'm just going to copy this actually. Okay. So what's different between the two? Let's see. This checks out. This checks out. This does not check out. However, if you recall, this is an imaginary 1, and 1 minus 0.1 gives you 0.9. So this, all they did is they simplified the x coefficients is what they're called. So this is the same equation, just a little bit simplified. So this also has the same solution. And again, you could check all of this in Desmos if you prefer. Okay? All right, how about this one? How's it different? Okay, this is unlike the one up above. This one, they got rid of the $2.70. However, it's still the same on the right-hand side. So all they did is they subtracted 270 from the left, but not from the right. So this is, and we're going to say that, subtracted $2.70 only on left side. Okay, so that's not an equality property. So this is not going to be 60. It's not going to be the same solution because they modified it too much. Okay, all right, next one. Same idea, right? Okay, so they subtracted 270 on the left, but then on the right-hand side, if you look at the difference, they added 270. Okay, so this is subtracted 270 on left, and yes, I'm abbreviating here, and added 270 on right. Okay, that's not an equality property. You have to do the same thing to both sides. So if you subtract here, you got to subtract here. So that's also not the same solution. Okay, and then lastly, equation F. Okay, you got the original equation, and then they're multiplying by 2, but they didn't multiply the right side by 2, did they? So they multiplied left side by 2. Okay, well, that's not going to be the same solution, because when you multiply, you have to multiply both by the same amount. So if it was going to be the same, they would have to do this, right, with all that in the parentheses, equals that as well. Okay, that would have been the same solution. But the fact that they only multiplied the left-hand side, it's not good, okay? So how do we know when they're equivalent expressions or equations? Again, it's when, number one, when they have the same solution, okay? So if we were to plug them into the graph. And number two, if they are the same equation, right? So in this case, if you subtract 270 from both sides, if they're equivalent equations, then you know that they're going to be the same solution, and or if they use a property that you're allowed to use, okay? So the moves, distributive property, applying the same amount to each side, dividing each by the same number, and so on, might be familiar because we perform them when solving equations. Solving equations essentially involves writing a series of equivalent equations that eventually isolates the variable on one side. So remember, we're always trying to solve for one variable. All right, let's go ahead. If you would like to try the cool down, you can do that. Okay, so you're going to try this. I'm going to come back tomorrow and go over that. And you're also going to complete these 4 practice problems at the bottom, and you're going to submit these for tonight's practice. Okay? All right, let me know if you have any questions, and I will see you guys tomorrow.